Now I've installed Nmap, I'll demonstrate its basic features. My first goal is to discover what hosts are on my network. I can do this by simply asking Nmap to check the network by entering sudo nmap -sn 10.1.1.1-60. In Linux, some networking functions will only work in superuser mode, so I use the sudo qualifier in front of the nmap command. Nmap has many functions which are selected by using options on the command line. Here I'm using the -sn option, which contacts each host in turn with what is known as a ping to see whether it responds. Nmap reports only the hosts that do respond, as we can see, and also provides the network interface level address, known as the MAC address of the host. I'll not use MAC addresses in this course, but they can be useful in advanced networking. I know already that the IP address space for my local network is 10.1.1.1 to 10.1.1.254. But by typing 1-60, I'm limiting this scan to just the first 60 addresses. The allocation of host addresses is usually done based on subnets, and the number of hosts is usually a power of 2, 4, 8, 16, 32, and so on. I can select a subnet to scan by specifying the number of bits starting at the beginning of the address, which are the same. Here, /26 selects 64 addresses, 0 to 63, although for practical purposes the address.0 is ignored. This makes managing the address range for the subnet much easier for computers, because this form of specification enables simple binary masks to be used. You will likely see a mask specified in your home network router as 255.255.255.0. That's a /24 address mask. Let's use this way of specifying subnets. I'll scan again, but this time using sudo nmap -sn 10.1.1.0/26 to look at 10.1.1.1 to 10.1.1.63. There are a number of other options when doing host discovery, such as taking an input file of host names, excluding specific hosts from a subnet scan, and so on. I won't cover these here, but you can have a look at the full list of options by entering nmap -h.